Okay, guys, we're going to start. Today we are covering 11.3. 11.3. We have the notes, probability of multiple events. And we have 11.3 practice and your calculator to start working with this. What is multiple events? What is events? We already went through that, right? Events, an experiment that we're doing, it has different results. Each one is an event. So we have two kinds of events. Before we start finding the probability of multiple events, we're going to find out what kind of event we are working with. If it is a two dependent events or two independent events. So how do we know when there's two dependent or independent events? It's very simple to show you what it is. For example, let's say we are rolling a cube and then we're spinning a spinner. So do you think one event has to do with the other one? The answers that we get from one event is going to affect the results from the other second event? No. So those two are independent. Independent events. And dependent is when the one event affects the other one. For example, let's see, we have a raffle in this class. And I have, let's say it's 25 students, I have 25 cards here. I'm selecting the first one. The last one is going to be the winner. The last card is in the container is going to be the winner. So if I get one event is going to get one out, right? You think the next one, the results for the next flash card that I'm getting out is going to be affected by the first one?
Yes.
Yes, right? First of all, because the probability is increasing. The probability, you're going to get more excited with, for example, if I get out of 25, I already took out 20, with the 5 there, then, oh my God, I have a better chance now to win, right? The prize. So every time I take one card, it's affecting a lot the rest of the students who are still in the game. So those are dependent events because one result affects the other one. You see what I'm saying? We're going to see some examples right now. And you have it in your notes. I put it right there. The idea is of writing all this stuff, guys, this is the kind of work you are supposed to be doing. I noticed it in the homework. Many of you guys are just turning in answers. No, because we're not doing algebra, that doesn't mean I don't have to work here. Just do the calculator and that's it. No. You have to explain to me in your own words what you're doing. That's exactly what I'm doing. All my problems have steps and formulas, and you have to show me that work, okay? It's different kind of work. So problem number 1, we're going to identify if we have dependent or independent events. For example, number 1, rolling a die or a regular cube, and then spin a spinner. Number 1, rolling a cube, a regular cube. It has 6 sides. And then spin a spinner. How are they? Dependent or independent? Independent, right? Because that doesn't matter what we get here. That doesn't affect what we're doing here, okay? So these are independent events. Even though we have only one word, I'm writing it down. The two events do not affect each other. That's why it's independent, right? They're independent. Number 2, pick one flashcard, then another from a stack of 30 flashcards. We already talked about that one. That one is dependent. So flashcards, 30 flashcards. And we are selecting one, right? And selecting one and then another one. Select one, then another one. Then these are dependent. Oops. Okay, guys. Problem number 2. In the problem number 2, we're going to use the probability of 2 events. And the 2 events are going on. You know, for example, here we have an example here. And the probability of those 2 events, probability of event A and B is going to be the probability of A times the probability of B. Okay? So, this example, we have, I'm just going to read it, I'm not going to write everything, you guys have it here, so you can read it as many times as you want. At a picnic, there are 30 diet drinks. You have 30.
10. Says 10.
Sorry. 10 diet drinks. And in the other one, and then there are also 5 regular drinks. Right? There are also 8 bags of fat-free, 8 bags of fat-free chips. Also, we have 12 bags of regular chips. Okay. If you grab 1 drink and 1 bag of chips, without looking, what is the probability that you get a diet drink and a free fat? We don't need that. Fat-free chips. So, how do we know? What is the probability of A and B? That's what it says. Grab a drink and grab a bag of chips. Okay? But specifically fat-free. Okay, so diet and so what do we do this? Probability of A. A is, we have 2 events here. One event is A, is the one that says selecting or grabbing a drink, diet, right? Diet drink. B is you are going to select a fat-free chips. Okay? So how do we find the probability of A and B? The formula says probability of A and B is multiply the probability. Probability of A, probability of B. How do I find the probability of A? Remember this? The favorable number of how many diet drinks do we have? 10. Out of how many in total? 15. How many fat-free chips do we have? 8. Out of all together, 20. So probability of A and B, according to the formula, multiply these 2 things. And that's it. So probability of A and B is probability of A times probability of B, and then multiply these 2 things. The answer is already in your notes. I'm not going to do all the work. You have it there. The answer is, remember, it could be fraction, it could be decimal, it could be percent. You have to be ready for any of those. If it's a fraction, multiply straight, like that, then reduce the fraction. If it is decimal, you're going to just divide the numerator and the denominator, which is 0.267. Oops, what happened? No, it's right here. So, the answer is 0.267. That's a decimal, or 26.7%. Don't forget that to put percent right there, you move the point to the right.
2 times?
2 times, yes. So that's the answer. Is there any questions so far? No? Let me restart this, because that's going to take like 3 days to put it. Okay, hold on.